Now we'll learn the algorithm for linear search. First, what you do? Start and you have to read the array elements, right? After that, read the search element. First, in the example, what have we done? First, we have considered the array elements. Okay. After that, what did I do? I will read the search element, the element which I want to find in the given array, right? After that, repeat for I equals to 0 to n minus 1. So each time what will I do? I keep searching. Okay. I keep comparing my search element with the array elements. From where will I start? A of 0 to n minus 1. Right. In case if somewhere here, if a of I, that means if a of 0 equals to search, I will get a message called element is found, or a of 1 is found, equal with the search element, again element found, right? Each time you are trying to search only one element, so that will be compared with the search element, right? So each time what happens? A of I value equals to search, right? So in case if my search element is not found, okay, what will I do? I plus plus will be done, right? I have to go and check the next element also, okay? So this is how you write the algorithm for linear search, okay? So now let us see how you write the code for linear search, okay? So I've took a function linear search, right? So I've sent parameters. My parameters are these 4 elements. This is my array, right? This is my array. Now in n is the size of elements, right? How many elements are there in this array? So maximum size is 4 and my search element is 9. So you can either, write this code like this with the help of functions, or you can directly take array elements. Okay, you can combine all the code in simply, right? So I can write here, take the search element here itself and write, okay? So I want you to know about the functions. So I've, implemented the code like this. So I equals to 0, right? I is less than n. So what is I value? 0. 0 is less than 4. Condition true. Okay. What is A of 0? 16. Is 16 equal to 9? No. It is not equal. So what happens? So I have to increment my I value. I became 1. Is 1 less than 4? Again condition is true. So what is there in A of I? That is A of 1. So 1 is there. Is 1 equal to 9? Again condition is false. Again I increment. So I became 2 right now. So is 2 less than 4? This condition is true. So what is there in A of 2? 9. Is 9 equal to 9? Condition true. So what it gets printed? Element is found at percentage D. What is this percentage D? Index. Right? What is the index? At what index my element is found? At 2. Okay. So after this, my cursor, the next return statement is there. So I will go back where my function is being called. Okay, this stop the execution. Okay. For suppose my search element is sum 16, right? So I've started 0 is less than 4, condition true. Is A of 0 equal to search? A of 0 is 16. My search element is also 16. Is it true? Right. My element is found at first position itself. Then I will store, I will print 0, index 0. My element is being found, right? Otherwise, there is one more case. My element can be this first example, my element is found at third position. Second example, my element is found at first position. What happens if the element is not found? Okay. For suppose my element over here is, this is 19 and this is my search element, right? So for while searching, I've searched with 0. Is 16 equal to 9? No. Again, I value is incremented. Is 1 equal to 9? Again false. Again, is A of 2 is 19? Is 19 equal to 9? Again condition false. Again, I value is incremented. It became 3. Is A of t equals to 9? 43. Again, it is false. Are there any elements to be executed? No. So, these statements are not going to be executed. So, after this, directly this statement is being executed. So, printf element is not found. Okay. Even if when you keep searching till the last element, if the element is not being found, then finally this statement will be executed. Element is not found. Right? This is how you write the code for linear search.